Most used fire alarm field wiring diagrams. Chapter 1. How to monitor two panel relays with one monitoring point. Here's a typical fire alarm diagram. Suppose you have to send signals to a central station. You're given a cellular dialer to hook up. When you open the dialer up, you notice it only has alarm and trouble zones. You open up the manual and find out the dialer needs a normally open alarm contact and a normally closed trouble contact. So, you wire it up like this. Terminals 5 and 6 have the resistor in parallel with the normally open alarm contacts, and terminals 7 and 8 have the resistor in series with the normally closed trouble contacts. But what happens if the panel goes into supervisory mode? The supervisory contacts won't report to the central station. You'll have to wire the normally closed supervisory contact in series with the normally closed trouble contact so that if either one transfers, the dialer will send a trouble. Chapter 2. How to shut down a 120-volt air conditioner blower. It's not a good idea to put 120-volt line voltage on an intelligent relay. Surges or dirty power can sometimes get through the relay to the panel. The best solution is to add a conventional relay between the 120 volts and the intelligent relay. Let's say you are shutting down an air conditioner. So, wire it up like this. The intelligent relay only has to switch the auxiliary power from the panel. The conventional relay switches the 120 volt power. The conventional relay separates the 120 volt from the low voltage because there is no electrical connection across the relay. It only physically opens the contacts. Always switch the hot leg of the 120, never the neutral. Chapter 3. How to activate a high amperage siren with a low amperage relay. Suppose you have to activate a siren that draws 1.5 amps with an intelligent relay that can only pass 0.5 amps. Use a conventional relay between the horn and the intelligent relay. The siren will draw its full 1.5 amps from the auxiliary power, but the intelligent relay will only draw about 0.1 amps that is required to activate the conventional relay. Chapter 4. How to monitor a flow switch and a tamper switch with one monitor module. In the old days, before there was such a thing as a supervisory signal, tampers used to send troubles. In an old system, you might see one monitor module monitoring both a tamper and flow. Here's how it was usually wired. When the flow switch activates, it closes the circuit and causes an alarm. When the tamper activates, it opens the circuit and causes a trouble. Here is what it looks like schematically. Chapter 5. How to supervise a 120-volt smoke detector with a relay base. Smoke detectors that get their power from wires other than the sensing wires are called four-wire detectors. Four-wire detectors with internal sounders are often used in hotel rooms. Some larger hotel suites have 2 or more detectors in them and are monitored with one intelligent module. They are wired this way. The sensing wires come from the monitor module and are paralleled across the normally open alarm contacts. One leg of the sensing wire is broken at each normally closed trouble contact. The resistor is paralleled across the sensing wires past the last detector. If someone takes out a detector, the sensing zone opens up when the plug separates from the base and the zone goes into trouble. Chapter 6. How to monitor 120-volt power with a fire alarm system. 4-wire 120-volt smoke detectors come with batteries, so it is not necessary to supervise the 120-volt power. But what if the authority having jurisdiction demands that? An easy way to do it is wire the input side of a 120-volt relay to the 120. Then break one leg of the sensing wires before the resistor using the output side of the relay. Notice that the sensing wires are landed on the terminals labeled common and normally open. This is because most relays are marked in the not energized state. This becomes so confusing that it's always best to meter the output contacts when the relay is in the state that you want it in. Since we want the sensing wires to be normal when there is power, we hook our wires up the reverse of the way it's marked. Chapter 7. How to change a normally open contact to normally closed. Some panels only have normally open supervisory contacts. But what if you have to hook up a cellular dialer that uses normally closed supervisory treble inputs? Switch the auxiliary power through the normally open supervisory contacts to trip a relay. Then wire the cellular dialer to the normally closed contacts on the relay. Note, only the supervisory wiring is shown here. For clarity, the alarm and treble wiring is not shown. Chapter 8. How to trip 3 controls with one panel relay. What if you have to trip a cellular dialer, a door holder, and a fan shutdown from one panel alarm relay? Switch the auxiliary power through the normally open panel alarm contact and have it trip 3 sets of relay contacts. Chapter 9. Basic Concepts. You must keep different voltage sources separate. Relays let you do this because there is no electrical connection between the inputs and the outputs. Not only are the inputs and outputs separated, but the 2 sets of output relay contacts are also separated, so you can put different voltage sources on each of them. Not keeping voltages separate can result in malfunctions, equipment damage, injuries, or death. Normally closed contacts are wired in series so that when any contact opens, the circuit will open. Normally open contacts are wired in parallel so that when any contact closes, the circuit will close. Feel free to voice disagreements or make clarifications. I hope this video will be useful.